All right, everybody, I wanted to talk a little bit about molarity and give you some tips and tricks for molarity types of problems. So as a reminder, molarity is a way that we can express concentration. So if I have my, oh, come on, pen, sorry, it does weird things sometimes. Here's my little beaker, and we'll use this. This will be my, I take a certain amount, like maybe, let's say 12 grams of some substance, sodium nitrate or potassium hydroxide. There's a lot of different chemicals this could be. And I put it in here and I dissolve it with a certain amount of water. I need to be able to express how concentrated I have made this solution. And I need to be able to do that for a number of reasons. One is safety. The concentration of a solution can determine whether or not it can go down the drain. It can determine whether or not we need to do it in the fume hood, the experiment. It can determine a lot of things about the safety aspect, but also in terms of if I want to do chemistry with this, I need to know how many of these little particles, which we're going to count mostly in moles, how many of them are in there. There are lots of different ways that concentration can be expressed, as you guys learned this week. You've got like percent-based concentrations, like percent grams per 100 milliliters, or volume concentrations. But molarity, which is kind of a go-to favorite for chemists, is mole of solute per liter of solution. So that's also how you're going to calculate it. You take the total moles divided by the total liters, and you're going to get this number that tells you how many moles there are per liter. So think of all the different units that you've learned in class or in school in general, or in your personal life, that are that. They compare one thing to another in terms of like a ratio. An example we talked about this quarter is density, grams per milliliter. But also when you drive your car, you're driving down the freeway, if your car's going 65 miles per hour, it means it's the same idea of this per this. In 1 hour, you're going to drive 65 miles. If you go 65 miles, it's going to take you 1 hour. And so whenever you have that, that can be a really useful tool because it can allow you to do certain calculations. So for molarity, we can express how concentrated we've made this by through its molarity. And it might get a number, like, for example, if you see a container that says this on the outside, you know that it is 3 molar sodium hydroxide. So that means no matter how much of it you have, there's a ratio of 3 moles for every 1 liter. So what are you going to do with molarity problems, or how could molarity problems look? So I think the most common ones that we're going to see at this starting level are find the molarity. Find the molarity. That's our most common thing you're going to be asked to do. And so in all of these, in one way or another, no matter how it's worded, you are going to be asked to do this: the moles of something divided by the total liters of the solution. And that's going to give you then that ratio. Now, how you're going to go about this is going to depend a little bit on the information as it's provided. And this is why chemistry is it's a lot of problem solving, a lot of mathematics. It's like science and math had a baby, and that baby is chemistry. So I think there's kind of three main ways you might have a problem where you have to find the molarity. So the first one is you're given the number of moles. So a problem's going to say something like you have 5 moles of sodium hydroxide and you dissolve it in 1 liter of water. What's the molarity? That one's pretty easy. It's 5 divided by 1 is 5 molar. So you're given the number of moles, and you're going to be given the volume, and you divide the two. Now you do have to make sure the volume is in liters, because by definition, so you might have to do a conversion, but these ones are going to be your most straightforward. You're given the number of moles, you have to be given a volume, you might have to convert it to liters, and you do the math. Now a second one, which is far more realistic, is that you are given grams. And the reason I say that's far more realistic is because, up here when I was like, oh, I took 12 grams. Well, that's because I don't have anything in the lab, in my laboratory, the secret one under my house. I don't have anything that can measure out a certain number of moles of a substance, because that's going to be unique for each substance. So I don't have a molometer, as I always say. But I do have a balance. And so you're much more likely to see a problem where it says, okay, if you take 5 5 grams of some chemical, like for example, sodium hydroxide. 5 grams of sodium hydroxide. And you dissolve it in this much water. Total volume is 175 milliliters. So you're always going to have a volume 2. So in this case, when you do this, you can't just take the 5 and plug it in here, because that's not what molarity is. But in the last unit, we learned what to do with that. We can convert from grams to moles using our periodic table. So in order to do that, we need to use the molar mass of the substance from the periodic table. So I don't want to do the math on this, I'm lazy. So let's say I wanted to figure out water. Well, that doesn't make any sense. Come on, Mrs. B, pull it together. I'll go ahead and do the math. So 5 grams of sodium hydroxide, but I want to get to moles of sodium hydroxide. So I need to, you'll see that you can tell my grams needs to go on bottom because I have to cancel it out. So you can see I would actually be dividing by the molar mass because they're every 1 mole. So how do I get the molar mass? This is review from our last unit. I need to use the periodic table where I see that sodium hydroxide is 22.99. I always go 2 places past the decimal. Oxygen is 16.01. And hydrogen is 1.01. And then I'm going to total those all together. You do check for subscripts, and that would be my number down there. And then I would have then the number of moles, and I could divide it by the total number of liters. So that one's far more practical because that's the kind of real life situation. I can't, say, hey, student, please go to the lab and get me 5 moles of sodium hydroxide. You're going to have to actually measure out a certain mass of it. And then the other way that you might be asked to find molarity in a problem is through titration problems. Titration, I'm struggling with this one today. They're I don't want to say just like they're simple, but they are find the molarity problems. So you have to do this in a titration problem as well. You have to figure out what's the volume of my solution, and usually it is given in milliliters because a liter is actually a lot. And then you convert it to liters, and then you have to figure out the number of moles. The difference is you're not given the number of moles, and you're not given a mass. In a titration problem, what you're given, you are given a volume of titrant. And you have to use that volume of titrant to figure out then how many moles of the substance that of titrant was used. So the titrant is the one whose molarity you know. So I'm going to say moles of T for titrant. And from the molar ratio in the equation, then you can get to moles of your unknown, the one you don't know. And I made a whole other video on titration, so I don't want to spend too much time on that. So find molarity. You're going to be given the number of moles and a volume. You always have to be given a volume. So I didn't write it, but you're always going to have the total volume of the solution. If you're given the number of moles, these are my favorite and the most straightforward. You're just going to divide the 2, check your sig figs, and you can use either this as your unit or the capital M. If you're given the grams, you do have to do a step first where you use the molar mass of the substance to get to moles, and then you can divide. If you're doing a titration problem that asks you to find the molarity of your unknown, you have to do a little stoichiometry first. You have to take the volume of your titrant, convert it to moles, and then convert it to moles of your unknown. So those are kind of really common ones, and there is I believe, some extra practice on molarity on Canvas. Now the other thing the second thing for molarity is find molarity. Instead of finding it, you can use the molarity. Use molarity. So in these kinds of problems, you would be given a molarity. Molarity given. And you have to use the given molarity to figure out either the number of moles or the number of grams. So for example, it could ask you for the moles needed. or how many moles are in. So it could ask for the number of moles. So if I said, like, let me just show you kind of an example because I think I'm being confusing. How many moles are in 50 milliliters of a 5 molar sodium hydroxide solution? I'm going to abbreviate solution because I'm feeling lazy. So you can see how this is different than just asking for the molarity. It's already given the molarity. Instead, it's asking me to use molarity. So in this case, I'm going to go ahead. Let's convert this to liters right away because I've already said over and over, you know, we've got to be in liters for this to work. Instead, what I'm doing here, rather than figuring out what the molarity is, I'm using the molarity to convert to moles of my substance. So I want moles of sodium hydroxide up here, and I want liters down there. So you can see from this that my 5 moles per 1 liter. And when I would do that math, and to save me some time on the video so I can get through more, I'm going to allow you guys to do that. So it would be this many liters, so the liters cancel out, and then I would have, that's how many moles. Now, it could have, because again, moles aren't always very practical, it could have said how many grams. So how many grams do I need? You know, I want to make a sample, in which case I just have to have done this step and then do the next step as well. So convert the moles. So I'd have to find the moles and then convert to grams using the opposite of our technique up there. And then, of course, a titration problem actually also kind of belongs down here, because in a titration problem, this step right here, going from the titrant volume, so in our titration problems, we also have to use a molarity, because you have to know the molarity of your titrant. So we have to use the molarity of titrant to do this step right there. And I don't know if that helps, if that clears up anything on what molarity is and what we want to be able to do with it, but I hope that it made something click for you. And continue to send me your questions and look at those practice problems that are available on Canvas. And Tito says hello.